welcome back to this channel. Nice to see everyone again. And for today's video, it will be the part 2 of your chemical reaction of carbonyl compound. And in this video, we'll cover 3 things. The first one is your Bready test. The second, we'll discuss about Tollens test. Last but not least, we'll go into your Iodoform test. All this will be the chemical test for carbonyl compound. So let's jump straight into the first one, which is your Bready test. So talking about Bready test, what is actually the function of Bready test? The function of Bready test is to identify the presence of carbonyl group. So if you have a C double bond O, whether it's an aldehyde or is a ketone, both will give you positive towards Bready, because you are having your carbonyl group, your C double bond O. In the other words, your Bready will be used to differentiate aldehyde and ketone from the other functional group. For example, you can differentiate ethanol from ethanoic acid, because your ethanol right now is a 2-carbon aldehyde, while your ethanoic acid is a COOH. So ethanol will give you positive Bready. So that is the function of Bready test, is actually to identify the presence of carbonyl group, your C double bond O. Okay. Next, what will be the reagent and condition of Bready test? Bready test will be using something very new to you, which is your 2,4-dinitrophenylhydrazine, or the short form is your 2,4-DNPH in capital letter. So what is actually 2,4-dinitrophenylhydrazine? So you have the word phenyl over here, which means you have the presence of your benzene ring. Hydrazine as your parent. Hydrazine is actually your N, single bond N. Okay, complete it with your hydrogen. One nitrogen can be holding 3 bonds. So complete the 3 bonds with the hydrogen. And then you have your 2,4-dinitro. Obviously, this carbon that holding hydrazine will be carbon number 1. Carbon number 2 over there will be holding a nitro group. 3, 4. So carbon number 4 will also be holding a nitro group. So that is your 2,4-dinitrophenylhydrazine. Your hydrazine as your parent, your phenyl group as your substituent, having 2 nitro group attached. Simple. Next, what is actually the observation for Bready test? If it's a positive Bready test, then you will have a bright orange or yellow precipitate form. The color of the precipitate will be very bright, so that is an example of your bright orange, and that is your example of your bright yellow. You can see that they are actually precipitate. Alright, all this is actually your precipitate. Next, let's look at the chemical equation of Bready test. The chemical equation of Bready test is definitely between 2,4-dinitrophenylhydrazine. So I hope you can see that the presence of your hydrazine over here. So that is your hydrazine. Your phenyl group as your benzene ring, and your 2,4-dinitro, where this carbon will be carbon number 1, 2, 3, 4. So you have your 2,4-dinitrophenylhydrazine. And definitely is about the presence of carbonyl group, so that is your carbonyl group, your C double bond O. And the group that involved over here is quite simple. It's between the NH2 that you have and also the O that you have. Okay? So let me expand the NH2 first. The NH2 over here can be formed like this. It's a single bond H. And what happened, guys, is the hydrogen that attached to the NH2 will be removed. And also the O over here will be removed. So the nitrogen is the one that losing the hydrogen. The carbon holding double bond is the one that loses the oxygen. And the rest of the group that doesn't change over here shall remain unchanged. So I will still have my phenyl. I will still have my nitro group that is unchanged. And over here, I will still have my NH that is unchanged. And then attached to the N that loses 2 hydrogen. Then it will connect to the double bond between the C double bond O, the double bond over here, and attached to the C that holding 2 bond. Attached to the C that holding another 2 bond. And this is the product that you will form from your Bready test. The main group that we focus on is your NH2 and also your C double bond O. And we will combine the nitrogen that loses the hydrogen and also the carbon that loses the oxygen. So this is the combination over that. And the rest of the group will be just recopy. You can just simply recopy this group. Okay. So this is actually your bright yellow or orange precipitate form. Alright? Simple. So we only focus on the NH2 group and the C double bond O. Let's look at another example. So again, that is my 2,4-dinitro phenyl hydrazine, which is also called as 2,4-DNPH. And this is my aldehyde. Due to the presence of your C double bond OH over here, that is my aldehyde. But the only group that we care is not whether it's aldehyde or not. We only care on the NH2. And then we only care on the C double bond O, the O over here. Same thing, let me expand the hydrogen for a bit. The H2 is actually like this. Knowing that, we'll remove the hydrogen that you have on the nitrogen and also the oxygen that attached to the carbon. So this is the nitrogen that loses the hydrogen and this is the carbon that loses the oxygen. So the new bond will be formed between the nitrogen and also the carbon. Okay. Recopy the entire group that doesn't have any changes. So my entire benzene ring shall remain the same. Having the nitro at the correct position, that is my 2,4-dinitro. My hydrazine still holding the NH and the N that loses 2 hydrogen. Bonded double bond with the carbon over here. So this carbon right now holding 1 hydrogen, holding carbon with 3 methyl group over here. And this is the product form in Bready test. Simple. Bear that in mind, we only focus between the NH and also the carbon that holding double bond O. And the new bond will be formed between the nitrogen that loses the hydrogen and also the carbon that loses the double bond O. Simple. Another example maybe. So you have your NH2 is the group that we focus on and also the oxygen that we focus on. You know that your H2 will be removed, your O will be removed. So this is the nitrogen that loses the hydrogen and this is the carbon that loses the oxygen. So you need to form a new bond between 2 of these atoms. And the entire group that doesn't change shall remain unchanged. So you have your NO2 over here. You have your NO2 over here that should be sitting on the same place. That is your NH. Bonded single bond with the N. And the N loses the hydrogen already. So it will connect to a double bond to the carbon that holding C double bond O just now. And this carbon right now holding CH2, CH3 and holding a cyclic 5 carbon. Simple, easy. And if you look at it, that is your 2,4-dinitrophenylhydrazine. That is actually your ketone. So it doesn't matter whether it's a ketone or aldehyde. It does matter is, do we have the C double bond O? As long as you have the C double bond O, you will be positive Brady, whether you are an aldehyde or a ketone. Okay? And this entire group that you form when you have a C double bond N attached, that will be your bright yellow or orange precipitate. Okay, and that's it about Brady. Simple, straightforward. Make sure you can draw your 2,4-dinitrophenylhydrazine. Okay, next, let's jump into Tollens Test. So what is actually Tollens Test? The function of Tollens Test is to differentiate the aldehyde from ketone. In the other words, aldehyde will be positive result, ketone will be negative result. That's why we say that it's going to differentiate aldehyde from ketone. Aldehyde will be the one that giving you positive observation. The reagent and condition that we are going to use in your Tollens Test is your AgNH3 bracket 2 charge positive 1. The name is actually your ammonical silver nitrate. So that is actually your ammonical silver nitrate that we will use in the Tollens Test. The condition must be in alkaline condition, therefore it must have the OH minus. So your Tollens Test will be using your AgNH3 2 positive and also OH minus. That is the reagent and condition. Next, what would be the observation of Tollens Test? The observation of Tollens Test is very beautiful because you'll be forming a silver mirror. The silver mirror that you form will be coating the test tube or any of the flask that you use, and you form a very nice silver mirror over here. And the silver that you form over here is actually your pure silver precipitate. Alright? And bear that in mind, for the Tollens Test, this silver mirror will be formed only for aldehyde because your Tollens Test is only positive for aldehyde. Okay? How should the chemical equation look like? The chemical equation is very, very simple. You have the presence of your aldehyde over here. And obviously, it's an aldehyde because you have a C double bond OH. And you react with your ammonical silver nitrate, AgNH3 2 positive, in an alkaline solution. And what will happen is the H will be removed, replaced by O minus. So your product will be as simple as C double bond O remain, the H removed and replaced by O minus, and then forming a silver mirror precipitate. That's it. Alright, so it's really simple, and that's why it must only happen to aldehyde because it's the hydrogen that we remove and replaced by the O minus. Let's look at some example. So that is my aldehyde, your C double bond O with the presence of your hydrogen. That is my ammonical silver nitrate in the alkaline condition. So what happened, ladies and gentlemen? Simple. The H at the aldehyde, the H that sitting with the carbon that holding double bond O will be then removed. And this H will then replaced by O minus. The rest of the group that doesn't change shall remain unchanged. You just copy them back. Everything will remain unchanged. And the carbon that holding double bond also remain unchanged. But the hydrogen that you remove replaced by O minus. And also you have your silver mirror form. And that is your Tollens Test for aldehyde. What happens when you are having a ketone? If you look at your ketone, you realize that your C double bond O having no hydrogen attached. When the C double bond O don't have a hydrogen attached, there will be nothing to remove. That's why for your ketone, there will be no reaction. Because there is no hydrogen that you can remove. Alright, no hydrogen attached to the carbon that holding C double bond O. Alright, so it will be negative Tollens Test. Next, how do we use this chemical test? Obviously, this chemical test will use to differentiate aldehyde and also ketone. So when the question asks you to suggest a chemical test to differentiate propanol and also propanone, the only chemical test that you should come into your mind is your Tollens Test. And as always, guys, chemical test you should always answer in a table. And your table will always having these 5 things. The first and foremost, the name of the test that you will be using is your tolerance. Don't do spelling error. The reagent and condition that you'll be using definitely is your ammonical silver nitrate. So you have your AgNH3 bracket 2 of them and positive charge with a OH minus. That is the reagent and condition for your Tollens test. And the compound that you're having over here is your propanol. And your propanol is a 3-carbon aldehyde. So it's actually something like this. Your C double bond OH. And your propanol is actually your 3-carbon ketone. And we know that the Tollens test will give positive to aldehyde. Bear that in mind. So who is your aldehyde over here? Your propanol obviously is your aldehyde because your ketone is between carbon and carbon. So which one will give you silver mirror form? Your propanol will be silver mirror form. Well, for your propanol, there will be no silver mirror form. Bear that in mind. Okay? Simple. Next, the chemical equation of propanol, also very simple. You have your CH3, CH2, C double bond OH, reacting with your Tollens reagent, which is your AgNH3, 2 positive with the presence of OH minus. The hydrogen will be removed and replaced by a O minus. So you produce CH3, CH2, C double bond O, O minus, and also presence of your silver mirror. Okay? And knowing that your propanol will have a negative result with ketone, so for the equation, you can just simply put it down, reacting with your ammonical silver nitrate and having no reaction because it's a ketone. So by that in mind, Tollens test over here will only give you positive result towards aldehyde by simply removing the H and replaced by the O minus, forming your silver mirror. Okay, so that is your Tollens test for aldehyde. And how do we use it? We always use it to differentiate aldehyde from ketone. Okay, simple. Next, let's jump straight into our last chemical test, which is your iodoform test. So what is the function of iodoform test over here? The function of iodoform test is to identify the methyl carbonyl group. What is your methyl carbonyl group? Carbonyl is definitely the group that holding C double bond O. Your methyl group is this. So this is your methyl carbonyl group, where you have a CH3. You must have a CH3 directly bonded to the carbon that holding double bond O. That is your methyl carbonyl group. And the reagent and condition will be the same as previous, where the reagent and condition for iodoform test is your I2 in NaOH. Simple. It's the very similar thing as the previous iodoform, but right now we are not checking the methyl carbonyl. We are checking the methyl carbonyl group. That is the only difference. What would be the observation? The observation of iodoform test will be the same, which is your pale yellow precipitate form. And your pale yellow precipitate again is your CHI3 precipitate. And your pale yellow precipitate will be looking exactly the same as previous. That is your CHI3 pale yellow precipitate, which is your triiodomethane. Okay? Simple. Same thing. Very, very similar. But only the function is different. Right now, we are checking the methyl carbonyl group. Okay? The chemical equation is also very similar. It's very simple and straightforward, where you must make sure you have your methyl carbonyl group. So that is your methyl, your CH3, your carbonyl C double bond O, and this is the group that we are looking for, your methyl carbonyl group. And what happened, guys? Very simple. We only focus on the methyl group that you have, CH3. We will remove the CH3 and then substitute with O minus. That's it. So the product that you form over here will be your C double bond O remain unchanged. The CH3 is being removed and replaced by O minus, forming the byproduct of your pale yellow precipitate, CHI3 precipitate. And that is the chemical equation of your iodoform test in carbonyl group. Okay? It's very simple. You just remove the CH3 replaced by the O minus. Let's look at some example of this. The first one, you have a ketone over here because you can see that you have a C double bond O sitting in between carbon. So that is your ketone. And the most important thing is not whether it's ketone or aldehyde. The most important thing is having this methyl carbonyl group. So that is your methyl carbonyl group over here. And what happened, guys? CH3 out replaced by O minus. But the rest of the group over here doesn't change. So we recopy the whole thing. That doesn't make any changes. Even the C double bond O is not changing. The only thing that changed is your CH3 is being removed, replaced by O minus. And then forming a byproduct CHI3, your pale yellow precipitate. Easy? Simple. Another example over here, same thing. We only focus on your methyl carbonyl group. So having this methyl carbonyl group, the same thing again. CH3 removed, replaced by O minus. And the rest of the group shall remain the same. You have your O minus replace the CH3. The C double bond O remain unchanged. The 5 carbon ring remain unchanged. And also forming a byproduct CHI3 precipitate. Your pale yellow precipitate. And that is your iodoform test. Simple, easy. So when the question asks you to suggest a chemical test to differentiate butanone and 3-pentanone. So the problem over here is you cannot use Tollens, you cannot use Brady. Because butanone having a C double bond O, pentanone having a C double bond O. And both of them are ketone. So when both of them are ketone, Tollens is not functioning. So when both of them are ketone or when both of them are aldehyde, the only thing that you can use is iodoform test. And the same thing, ladies and gentlemen, to answer chemical test, we always answer in the table. And in your table, you're always having these 5 same thing. And right now, since I'm having butanone and also 3-pentanone, I will then start off with my iodoform test. And in your iodoform test, you'll be using your I2 and AOH. And your compound right now is butanone. So you can draw your butanone. Butanone is a 4-carbon ketone. So you have your CH3, C double bond O, CH2, CH3. That is your butanone. Your 3-pentanone over here, which means it's a 5-carbon ketone where your carbon number 3 holding the double bond O. So your 3-pentanone should look something like this. Carbon number 3 holding double bond O and complete the 5 carbon. And looking at your butanone and pentanone, which one will give you positive iodoform? The one that having methyl carbonyl group. So your methyl carbonyl group is a C double bond O holding CH3 on the same carbon. So which one having methyl carbonyl group? Obviously, your butanone over here having methyl carbonyl group. So your butanone will be the one positive iodoform. Positive iodoform means what? Pale yellow precipitate form. While for the 3-pentanone, where you don't have the methyl carbonyl group, therefore no pale yellow precipitate form. Easy? Same thing as the previous iodoform. Next, writing the chemical equation. So your butanone over here, you have your CH3, C double bond O holding another 2 carbon to make it a complete 4 carbon ketone butanol. Reacting with your I2 NaOH, what will happen, guys? The CH3 of your methyl carbonyl will be removed, replaced by a O minus, C double bond O remain unchanged, CH2, CH3 remain unchanged, forming a byproduct CHI3 precipitate. So bear that in mind, we only focus on this methyl carbonyl group, and this methyl group will be removed, replaced by O minus, forming a byproduct CHI3 in your iodoform test towards butanol. Okay? And for your 3-pentanone, it's even easier because there will be no reaction. So you basically redraw the structure. Reacting your 3-pentanone with your iodine in NaOH will give you no reaction. Simple, easy. And that is your iodoform test in your carbonyl group, where we will focus on the methyl carbonyl group, which is your C double bond O holding CH3. And that is the end of this video. So I hope you understand the use of these 3 tests, your Bready test, your Tollens test, and your iodoform test. Make sure you know the function of the test, the chemical reagent and condition for the test, the observation, and also the chemical equation of the test. Always remember the function of the test before you use them. You need to know why we are doing the test. Okay? And I hope this video helps you to understand on your chemical test of carbonyl compound. If it does, don't forget to hit the like button and remember to subscribe to my channel. I'll see you again in the next video, and thank you for watching.